Hello students. So we'll start our topic in physics. This is vectors. So as you know, vectors is the topic with which you start studying physics because vectors will be useful in throughout the physics like from mechanics to electrostatics to magnetism. Throughout the physics you will need this chapter. So we'll start that. So first thing we'll see what is a vector quantity actually. So if you see the definition of a vector quantity, so a vector quantity is a quantity which is having a magnitude, which is having a direction, and it also follows the laws of addition of vectors. As I told you, let's say you have a mass. So if you have a mass m, and if it is given mass is equals to 5 kgs, then you know that this mass is a mass. It is having a magnitude, but it doesn't have direction, right? So mass is not a vector quantity. Now, so for a quantity to be vector, it should have a magnitude also, and it should have a direction also. But apart from that, it should also follow the laws of addition of vectors. We'll see what it is, because we'll see here a physical quantity which is current. So if you see current, so current in a wire, you can say that current is flowing from point A to point B in a wire. Let's say the current is 1 ampere. So we know that this current I is having a magnitude, and it is also having a direction from A to B. So is current a vector quantity? So it's having a magnitude, it's having a direction. But the thing is, it doesn't follow the laws of addition of vectors. We'll see why. So if you are familiar with the junctions law, Kirchhoff's junctions law and Kirchhoff's loop law, if you would have studied the same in 10th standard also. If not, no need to worry. So let's say there is a point A towards which there are two currents going, I1 and I2, and I3 also. So point A, there are two currents going, I1, I2 and I3. So if you see, and this is the resultant current coming out from point A. So if you see this resultant current, this is simply the sum of the individual currents, I1 plus I2 plus I3. And basically, if you see the resultant of vector quantities, it will not be simple sum of this. You'll see the addition of vectors. So you will understand this better there. But the point to note here is the third criteria should also be fulfilled for a quantity to be a vector quantity. Like it should follow the laws of addition of vectors. So there are triangle laws of addition of vectors. We'll see that. So this particular example is not following the addition of vectors laws. So it is not a vector quantity. So for a quantity to be a vector quantity, it should have a magnitude, it should have a direction, and it should also follow the laws of addition of vectors. So we'll see addition of vectors now. So how do we add two vectors? So let's say there is a vector A and there is a vector B. So vector A is also having a direction. Vector B is also having a direction. So vector A is having a direction, vector B is having a direction. And they may be having their own magnitude also. So what you basically do is, so the law which I am going to tell you is the triangles law. Okay. So addition of triangle law of addition of vectors. So you just try to shift the vectors in such a way that the head of one of the vectors and tail of the other vector joins each other. So simply you can understand, see there are some basic things which you have to understand. Let's say there is a vector A and there is a vector B. You can shift vectors parallelly. So this B vector can be shifted here parallelly. That is one thing. The idea is to understand is, let's say you start from a point O, go to point A in the direction of the arrow, and again go from A to B. Basically what you have done is you have gone from A to O to B directly. So this is your resultant vector. That is one thing. The other way you can understand is, let's say there is a vector A and you join it tail to tail. Let's say there is a vector. So let's say someone is pushing in this direction, and someone is pushing in this direction. What the resultant has to do, the resultant will go somewhere in between. So this is the range of the resultant. Somewhere in this region, the resultant vector has to go. So the resultant force will be somewhere in this bit. We'll see this, how it comes. So there is a vector A, there is a vector B given. So what you have to do is, for triangle law, you have just to shift, you can shift vectors parallelly anywhere. So we have to shift vector b such that vector b's tail coincides with vector a's head. So this is the other concept, that you actually start from here and reach here. Basically you have just done this. So this is your result. Same way you can understand this one. There is a vector A and there is a vector B. You just shift this vector B parallelly here so that it joins tail to tail. So what happens is, so this is the parallelogram being made. So what you can see here is the resultant has to be somewhere in between, right? No, because if someone is pushing in this direction and someone is pushing in this direction, the resultant has to be somewhere in between. All right. So this is your resultant vector. Now the thing is, it is the same as we saw here. If you see, this is vector b again, right? No, parallel to it. So this is a parallelogram. So this is again a parallel to it. So you can understand it in both the ways, if you join tail to tail or if you join tail to head, in this way. So any one thing you can remember. So basically this will suffice. So any one law, if you remember, it's okay. So what we did is we joined, we shifted A here and we shifted B here. So such that the tail of B joins the head of A. Now we know that we basically have done, we have moved from here to here. So that is the resultant of the vectors A and B. Moving from here to here with vector A and moving from here to here with vector B. Basically we have done is we have moved from here to here. That is the resultant. That is what the vector addition means. Alright, now the thing is, we need to find what this particular thing is. How much is the value of it, how much is the magnitude of it, and where is it. So for that, what we do is, if you see, if you just draw a perpendicular here, so if you see b, this perpendicular will be b sine theta and this will be b cos theta. So if you see this triangle, so this is basically a right angle triangle. So this is the magnitude of this particular line will be the hypotenuse. So that will be equals to this plus this square plus b sine theta square under root, right? So the resultant vector, so we denote with this symbol the magnitude of a vector. So the magnitude of the resultant vector will be equals to b sine theta whole square plus a plus b cos theta. So we assume here that the magnitude of a vector is a. All right. So if you solve this, you will get this. So the resultant vector, the value of the resultant vector, that is the magnitude of the resultant vector, is a square plus b square plus 2ab cos theta under root. Right. Now the thing is, you have got, since it is a vector quantity, you have got the magnitude of the vector. Now for a vector, for a quantity to be vector, it has to have a direction also. Now what is the direction of this resultant vector? One thing which we can assume is the angle alpha here. We can say that the resultant vector is at an angle alpha with vector A. Alright. So this can determine the direction of resultant vector, right? So the resultant vector is at an angle alpha with the vector A. So how do you see that? So tan alpha basically means what? In this triangle, if you see, in this triangle, tan alpha will be equals to b sine theta, the perpendicular, divided by the base, a plus b cos theta. So that is tan alpha is equal to b sine theta by a plus b cos theta. So this is the way to calculate the resultant of two vectors, where vector a and vector b is given and the angle between those two vectors is given. So here the angle between those, now we'll see what is this theta here. I just forgot to tell you what this theta is in the beginning. So angle theta is the angle between the vectors. When do we call that? What is the angle between the vectors is? When you join two vectors tail to tail, the smaller angle between them is called the angle between the vectors. So angle theta here is the angle between the vectors. So you can see here that this is joined head to tail. So if you protrude it here, so you can assume that vector A is here and this is joined like this. So you can see that the angle between the vectors when they are joined tail to tail, right? Now, so if you protrude this vector A here, parallelly shift it in this direction, then you can find that this is the angle between the vectors, right? Now, when they are joined tail to tail, the smaller angle will be the angle between the vectors. You won't consider this angle, right? You have to see this angle only. All right. So in terms of theta A and B, the resultant is this, and the direction of the resultant is this, right? Now we'll see the next topic. What is a unit vector? Now see, what is a unit quantity? Let's say someone is having mass 10 kgs. How do you get a unit kg? A unit kg means uh, the uh, the basic measurement unit which you are actually using. So unit here is 1 kg, right? So that is the unit measurement quantity in terms of kgs here. So how do you get that? So whatever the quantity you are having, just divide by its magnitude. So you get the unit physical quantity in that example, right? No. So similarly, what you have to do is for a unit vector, or let's say any vector, if you are having any vector, how do you want to get? Let's say there is a vector given a, and you need to, someone is asking you find the unit vector in this direction. So let's say this unit vector is represented by n cap. So we generally represent a unit vector with a cap. So in the same direction, if someone is asking what is the unit vector here in the same direction, that means what is the vector in the direction of a whose magnitude is 1. So magnitude basically is 1, and the direction is same as the direction of a. So how do you get that? We basically take a vector and divide by its magnitude, similar to this example. So you get the unit vector along a vector. Now, what are the unit vectors along x-axis and y-axis represented as? So we represent x-axis, the unit vector along x-axis as I cap, unit vector along y-axis as j cap, and unit vector along z-axis as k cap. So there are I vector, j vector, I cap, j cap, and k cap. So these are the unit vectors represented along x-axis, y-axis, and z-axis. That means the direction of this vector is along x-axis and its magnitude is 1. Similarly, the direction of this vector is along y-axis and the magnitude is 1, and the magnitude of this vector is 1, and it is along z-axis. Now, how do you resolve a vector? Resolution of a vector is, vector simply means that breaking a vector into two. What we have done till now is we have taken two vectors, vector A and vector B, and we have replaced this vector with a resultant vector, right? No. So simply what you can do is you can replace these two vectors and you can just say that there is only one vector R, right? So this is like combining two vectors, that is summing two vectors. So instead of this A and B, you could have told that there is only one vector R. Similarly, in place of a vector A, we can break this vector A into two components or three components, so as many components as we want. So it depends on the direction. So if we want to resolve this vector, so resolution is basically splitting a vector into more than one component. So let's say this is vector A and it is having an angle theta. It is having an angle theta with the x-axis. So you know that in this direction the unit vector is I cap. So what we basically can do is we can break this vector in two. So there will be one vector in this direction, and we can break this vector in this direction also, and we can say that instead of A, we are having two vectors, one is in this direction and one is in this direction. So we can just remove this vector and say that there are two vectors in this direction and in this direction, so in the x direction and y direction. Similarly, in the z direction also it can be. So we can replace vector A and we can say that there are three vectors, one in x direction, one in y direction, and one in z direction, whose resultant will be a vector. So how do we understand this properly? So we'll see. So let's say there is a vector A. We'll just see x-axis and y-axis for simplicity now. Same thing we can just extend for z-axis also. So let's say there is a vector A which is making an angle theta with the x-axis. So how we can split a vector is, we can write a cos theta in the x direction and a sin theta in the y direction. Basically, whatever axis it is making an angle alpha, let's say this is making an angle alpha here, let's say vector is making an angle alpha. So you can write a vector as a cos alpha j cap, or if you want to start with I cap only, so you can write I sin alpha I cap plus a cos alpha j cap. Basically, whichever axis the angle you know, that side the component will be a cos theta, a cos the angle, and the other side the component will be A sine. So if you see here, you just draw a perpendicular here and a perpendicular here. So you can see that this is basically, if you remember the triangle law of addition, this particular vector A is basically the sum of these two vectors, right? This vector and this vector, right? So triangle law of addition was like this only. So this is the sum of this vector and this vector. So you are going from here to here. So all what you exactly is doing is you are going from here to here. So this is the sum. So you can write a vector in terms of this vector and this vector. So what this vector will be, if you see in a right angle triangle, if this is A and this angle is theta, you can find that this is A cos theta and this is A sin theta, right? No, if you see cos theta is equals to base by hypotenuse and sin theta is equals to perpendicular by hypotenuse. So with this relation, you can find that if the hypotenuse is A, this particular, the base side will be A cos theta and the perpendicular side will be A sin theta. So similarly, what we can do is, in this particular example, instead of writing A, we could have written that there are two vectors. One is A cos theta in this direction and the other one is A sin theta in this direction. Now, this is the magnitude. So what is this direction represented as? We have seen that the direction in the x-axis is represented by I cap, the unit vector along that, and the direction along the y-axis is represented by j cap. So you can write basically A vector is equals to A cos theta I cap and A sin theta j cap, right? So this is how you resolve a vector. So if it is also included with z-axis, so some component will come along z-axis also. So you can write whatever the component comes along x-axis I cap plus whatever the component comes along j-axis, I mean the y-axis, j cap, and whatever the component comes along the z-axis, that will be k cap. So this vector A can be split into ax I cap, ay j cap, and az k cap. Right? We'll see this by examples. Alright, now can we just verify that this is correct? Okay, you can see that basically after you have split it, so instead of vector A, we can write it in terms of A cos theta and A sin theta. But does this combination of two vectors give you back the A vector? We'll see that. So we know that the resultant vector by the formula, right? So we know what is the resultant vector by the formula. So if you see, the resultant vector is given by, so we saw that the vector A can be split into two vectors, A sin theta towards the y-axis and A cos theta towards the x-axis, if it was making an angle theta with the x-axis, then only. Right now, so instead of A, we can write two vectors. Now the thing is whether these two vectors give back you the vector A. Can we check that? So you know that the resultant vector will be the first vector square, A square plus B square plus 2ab cos theta, right? No, so b square plus 2 into a b, a, this is a, into b is a cos theta, ab 2 into a into b into cos theta. What is the cos theta between these two vectors? Is 90 degrees, right? No, what is the resultant? So resultant vector is given by a square plus b square plus 2ab cos theta, where a is one vector and b is the second vector. What is the one vector here? First vector here is a cos theta or a sin theta, anything you can take. So a sin theta whole square. The second vector is a cos theta, that square, 2 into the first vector into second vector into the angle between them, right? So angle between them is now cos 90. So if you see cos 90 is equals to 0, you can so cos 90 is equals to 0 means the only term left is a square sin square theta plus a square cos square theta. If you take root, it is a square sin square theta plus cos square theta. So that is equals to a. So you know that sin square theta plus cos square theta is equals to 1. So it becomes under root of a square. So that becomes a. So the resultant is giving you back the original vector. So that's why what happens is sometimes when solving the problems, we need to resolve the vectors into one direction. I mean similar directions for all the vectors. Let's say more than one vectors have been given. So in that case, these kind of resolution will be very much pretty handy, so that you can use it in your problem solving, right? We'll see the next topic. All right, so the same thing as I was mentioning, we'll just try to solve a question. You can see this question. So we have to find the magnitude. We have to find the magnitude, x and y components, and the angle with the x-axis of the resultant of OA, BC, and DE. See, now three vectors are given. Now what we know is, we know the sum of two vectors, how to calculate the sum of two vectors. When more than two vectors come, that becomes very complicated to use a formula. So what we basically can do is, instead of OA vector, we will not use this. We will just split it into two components. Similarly, instead of BC vector, this was OA vector, we will not use this. We just split it into two vectors perpendicular to each other. And instead of DE also, we will split it into two vectors perpendicular to each other. And what we'll do is, we are not going to use the individual vectors. So we can use this, and this. So there will be totally this many of vectors. So each of in the similar direction can be added, each in the other direction can be added. So what we can do is, we can basically at the last you will get two vectors, in one in x direction and one in y direction. So these things are easy to solve. The resultant you can get, right? So this is how we proceed. So that's why we use resolution of vectors. All right, so what we can do here is, we will use OA vector first, and we'll see how we can resolve it. So if you see OA vector, what is the angle with the x-axis? Is 30 degrees. So as I told you, whatever axis it gives the angle, that will be cos 30. So this will be 2 cos theta. So that is 30 degrees. So that is 2 cos theta I cap. So if the angle is given with one axis, so that is cos, the other one will be sine. So it is 2 cos 30 j cap. So it becomes this one. So similarly for the BC, if you see, the angle is given 60 degrees with this. So in this direction it is 1.5 cos 60 in this direction, right? No, so if you split this vector, it will split in this direction and this direction. So this direction is I cap. So what is this direction? It is minus I cap, the opposite direction, right? So similarly, what you can do is, you can see here, it is 1.5 cos 60 degrees minus I cap, and you can see that 1.5 sin 60 degrees j cap, right? So BC vector becomes this one. What is DE vector? So if you want to split DE vector now, so how you can do is, so DE vector is altogether towards the y-axis, right now, in the negative direction of y-axis. So it is altogether this side only. You cannot take a component of a vector in such a direction where it is 90 degrees. I'll tell you how. Just see. Let's say there is some vector has been given. Let's say there is a vector. Let's say there is a vector A vector, and you need to find the component of this vector in this direction. This is perpendicular to this. So what you need to do is, so this is 90 degrees has been given. So you have to say that the component along this direction is A cos 90 degrees, right? And that becomes 0, because cos 90 is 0, right? So you cannot find the component of a vector in a perpendicular direction. That means a vector doesn't have its influence in the perpendicular direction. This statement is going to be very useful for your future chapters also. A vector doesn't have its influence or component along perpendicular direction, right? So along 90 degrees, it doesn't have its influence. So if someone is applying a force also, it doesn't, so you can see in projectile motions, if you want to see, the velocity will always be constant. If you see, if you throw something, if it is a velocity v initially, so v cos theta in this direction, if you remember something in projectile motion, and v sin theta in this direction, you can see that all throughout the motion, the velocity in the horizontal direction will always be same, because there is no force acting along the horizontal direction. The only force acting is towards the ground, that is mg, and this force is not having any influence in this direction because it is 90 degrees. So this way a lot of things will be very useful in your future chapters. So that's why if you want to resolve this vector DE in two directions, so this DE vector has to be resolved in two directions. So one direction it is already there, this direction it will be 0, and full DE will be in this direction itself. So that will be how much? 1 will be in minus j cap. You can see how it is. So what is the direction of DE? What is the angle of DE with respect to y-axis? Is it 0 degrees? I mean with respect to negative y-axis. So it is 0 degrees. So how you can find 1 cos 0 minus j cap? So that becomes 1 only. Right now D is equals to 1. So this gives you the component D basically is throughout only towards y-axis. So D can be written as 1 into minus j cap. So that is minus j cap. Now what you can do is the resultant is the sum of these vectors. So basically what you can do is you can add the I components together and the j components together. So you got this particular thing. This much. So basically now what you are left with, instead of two vectors you are left with only, instead of three vectors you are left with only two vectors, I direction and j direction, and you can simply sum this. So if two vectors are given in I direction, something, let's say A in I direction and B in j direction, how do you sum it? The resultant how you will get? So the resultant will be under root of a square plus b square plus 2ab cos theta. So this will be simply a square plus b square under root. Why? The cos theta terms, the angle between the vectors is 90 degrees. That the cos theta terms disappears. That is equals to 0. Cos 90 is equals to 0. So this simply can be given by x square plus y square. So that is the resultant. So resultant magnitude will be, if you solve, you will get this 1.6 meters. Now the second question was x and y components. So you know that you have already split it into I and j. So this is the x component and this is the y component. This is the y component. Now the thing is, now they are asking is what is the angle with the x-axis of the resultant. So now you know that, let's say this is the resultant. So this resultant has been resolved into only two components, this and this. So if this is the angle, let's say x-axis, angle x-axis theta, this is alpha, then what is the resultant given by? This divided by this. No, tan alpha will be this divided by this. Right? So you can simply take tan alpha will be this divided by this, or you can use the formula also. So tan alpha was what? B sin theta by a plus b cos theta, the addition of vectors, right? No, so you know that the angle between the vectors is 90 degrees now, because you have resolved it into two components, one is I and one is j, and the angle between these two are 90 degrees. So that becomes, this becomes only b divided by a, because this component is 0. So this way also you can understand, and you can understand with the diagram also. So if you get this, tan alpha will come as 1.32. So this is the way you solve this kind of questions, right? Now what is the influence of component of a vector in the direction perpendicular to itself? Is 0. This is what I just explained in the previous slide. No? So let's say there is a vector a and there is a angle theta here. So the other direction is perpendicular. So we say that the component of this vector along this side is a cos theta and it is a sin theta along this side. Now let's say if someone asks you a component along 90 degrees, as I just told you in the previous one. So this will be a cos 90 degrees, that is equals to 0. So there is no component of a vector along perpendicular direction, perpendicular to itself, right? No. So let's say if a vector is represented something like this. So let's say a vector a is given along x-axis itself. So if you write a vector, you can just write, because there is no j component here, right? No, because the j component will be 0. Now how do we subtract two vectors? We have seen addition of two vectors. So there is a vector a given, there is a vector b given. So if we want to find a vector minus b vector, how do we do that? So now this can be written as a vector plus of minus of b vector. Minus of b vector basically means reversing the direction. Reverse the direction of b. Basically this means what? B vector is multiplied with minus 1. That means it is reversing the direction. So this is your a vector. If you see this is your a vector and this is your b vector. If you want to find a minus b vector, you just simply can do a vector plus minus of b vector. So what is minus of b vector? So if this is b vector, the opposite direction will be minus of b vector, right? So what you simply can do is, you are going from here to here and here to here. So this is your resultant. Now you can apply the same formula and all, which we had applied for the triangle law. So basically your triangle becomes this one now. So A, B, and the angle between the vectors is this one. So if you solve this by using the formula, you will get. So A plus B basically means, A minus B basically means A vector, sum of A vector and minus of B vector. Now, what is, we just saw sum and subtraction. Now we will see products. So for vectors, we have seen addition and subtraction. Now we will see products. So basically there are two kinds of products we will see. So that is, one is called dot product and the other one is called a cross product. So dot product is also called as scalar product because whatever the result is coming out of a dot product will be a scalar quantity. Scalar quantity means you don't have a direction for that. Okay, so it is defined something like this. So A vector dot V vector is equals to the magnitude of A into magnitude of B into the cos theta, and this is a scalar quantity. It doesn't have a direction. So there is a vector A and there is a vector B. The angle between them is theta. So A dot B basically gives you AB cos theta. Simply, that is just a magnitude. Now, if you see it in terms of I cap and J cap, you can see what is I cross I. I dot itself. So I cross I will be 1. How? It is I magnitude is 1 into, again I magnitude is 1. What is the angle between I and I? That is 0. So that is cos 0. That is equals to 1. Similarly this and similarly this. What about if we change? What is I dot j? If you see this, that is 1 dot 1 into cos 90 degrees. That is equals to 0 because cos 90 is 0. So you cannot dot a product. The dot product of two vectors perpendicular to each other will be 0. Right? Alright. So the example of these things, you will see that what is work done. If in your future chapters you will see that work done is defined as a small work done dW is defined as the force dot displacement vector, or the a small displacement dr vector. So this is given by dot product. Several other quantities will also be given, like kinetic energy is given, like, so a small change in kinetic energy is given by half into m v vector dot v vector. This is something like given by given for kinetic energy. You just forget about this. So now the dot product will be coming in your future chapters as definitions for something. Okay, so if you want to do dot product of two vectors, how we do? Let's say there is a vector A. This is A vector, and this is, let's say, B vector. This is B vector. If you want to do a dot product along this, we need to do this to this, this to this, and this to this, and plus this to this, this to this, the similar way. So if you see, I to I will be 1, I to others will be 0. I to, if you see this, I dot to I will be 1, others it will be 0 because the angle between I and J will be 90 degrees and I and K will also be 90 degrees. So basically what you have to do basically is you take the similar terms. So AX, BX, AY, BY, and AZ, BZ. This is how you do a dot product. You understood? Because the other components are going to be 0. Let's say if you do AX I cap dot BY J cap, it will be AX into BY into cos 90 because I and J are at perpendicular degrees, perpendicular angle. So that is 90 degrees. So that component will be 0. So it is basically AX BX plus AY BY plus AZ BZ. Right? So this is how the dot product comes. Okay. Now we'll see what is cross product. The result, what you get from a cross product is a vector quantity. That is also that means it is going to have a direction. That is why it is called as a vector product also. So how do we get that? So A cross B vector gives you A, the magnitude of A into B sine theta into a direction. So this is representing a direction actually. So because cross product is a vector quantity. But where will this direction be? So something you are doing on two vectors, you are just you are using a product thing. So that is called a cross product. So if you are doing something on this, you are getting another vector whose magnitude is AB sine theta, and it is also having a direction. But what will this direction be for a cross product? So basically this particular n cap, we are representing it by a unit vector here, so that it represents a direction. So this particular vector, the direction of this vector will be perpendicular to both A and perpendicular to both B. So this is a vector product. Now how do you get that direction which is perpendicular to both A and B? So there are two things which you can use. There's a right hand thumb rule which we can use. So you can see in this diagram, if you want to find here, if you want to find A vector cross B vector, what you have to do is you have to keep your right hand palm along the direction of A, along the direction of the first vector, and you have to cross it, and you have to curl it along the other direction, other vector, B vector, along the angle. This is the angle, not the other way around, not this way. So we have to curl it from this direction. Okay, so if you curl this, the direction of the thumb will be giving you the direction of A cross. So this is the direction of, let's say this is a plane in which A vector and B vector will be there. So this n cap, that is equals to A vector cross B vector. So the other way, okay, so A is this, B is this. So the perpendicular direction will be the perpendicular to this plane, right? So this will be the direction of A cross B. So this is the direction of A cross B, or maybe this direction. So which is both perpendicular to A and B. If you see in this example, if you curl from A to B, you will get this direction. So this is the direction of A cross B by this particular method, by the right hand thumb rule. There is another rule what you can do is, that is called as a screw rule, screwdriver rule. So what you can do is, what basically you can do is, you can keep a screwdriver here at this point. Okay, so there you can keep a screwdriver here at this point, something like, or you can keep a screw. What you have to do is, you have to just turn your screw from A to B. You have to keep the screw perpendicular to both A and B, and you have to turn the screw in a direction which is from the first vector to the second vector, and you can see which way the screw is going. Now if in this example, if this is your screw and you are turning this screw from A to B, you can see that the screw is coming upwards. So it is unwinding, so this screw will be coming upwards. So this will be the direction of your A cross B vector. Now for representation, since we will be studying from here on, we will be studying only on a 2D plane. So what we can do is, for representation of this, we can imagine it in this way, that this symbol represents a vector coming towards you, and this symbol represents a vector going away from you. How you can remember it? You can see an arrow. When an arrow is coming towards you, what do you just see? You just see a point, right? So when an arrow is coming towards you, you just see a point. When an arrow is going away from you, you will see this head. So that you will see as a cross, right? No, so the tail of an arrow, straight arrow, will be seen only as a cross. If you are seeing an arrow going away from you, so this particular symbol represents going away from you, perpendicular to your plane. So perpendicular to the paper on which you are writing, away from you. So that means if you are keeping a paper on a table and writing on it, so if a cross, if this symbol is mentioned there, that means it is going inside the paper away from you. And if this symbol is mentioned, it is coming towards your eyes from the paper, perpendicular to it. So this is how we represent directions of cross products. So we'll see them by examples. Okay, now let's see what about this I, J and K. So let's say we represent, no, this one is the I direction, this is the J direction. What is Z direction now? So I have represent the same thing, the dot. Dot means coming towards you. So Z direction basically means from a vector originating from this O and coming towards you. I cannot draw that on this plane, right? So it is coming towards you, something like this. So if I draw it in a different direction, it comes like this. So it is I vector, this is J, and this is K. All are perpendicular to each other. Now what is I cross J? It is 1 into 1 sine theta, so that is the angle between those two, and a unit vector. Okay, so that unit vector will be perpendicular to each other. So if you see this, so this becomes 1 into 1 sine 90, that is 1. This becomes 1. And what is this direction? If you turn the screw from I to J, you will find that it is coming along this direction. So that is equals to K vector, right? No, K unit vector. So if you do I cross J, you will get K. If you do J cross K, you will get similarly I. You can just try those things. J cross K means you will be turning from here to here. So you will find that this is the direction you are getting. Okay, and k cross I will be j vector. Now this is one thing. Now as we saw in dot, no, I dot I you will get 1, and I dot j you will get 0, but here it is opposite. You will get I cross I as something, but I cross j as 0, right? Oh, sorry, no. You will get I uh, cross I as 0 and I cross j as. So if you are taking different terms, then some answer will come. If you are taking similar terms, then answer will be 0, because sign 0 is 0. So if you see I cross I, it will be 0, j cross j will be 0, and similarly k cross k will be 0. Now how to remember it? You can see by turning your thumb and using the right hand thumb rule. But how to remember which one will be plus and which one will be minus? If you see this j cross I, this will be minus k cap. So if you do j cross I, if you do j cross I, it will be going inside, right? No, so this will be minus k cap. So this simple. So this is j cross I direction. Okay, so this is going inside the plane. Okay, away from you. So that is minus k. So similarly, which will be minus and which will be positive? For that, you can remember one thing. You just write I, j, and k. How do you get it? If you're doing in this direction, if your direction is correct, I to j, j to k, and then k to I in this cyclic direction, then everything will be positive. If you do I cross j, you will get k cap. If you do j cross k, you will get I cap. If you do k cross I, you will get j cap. But if you change the order, you are going to get the minus one. If you do j cross I, you will get minus k cap. If you are doing k cross j, you are going to get minus I cap. If you are doing I cross j k, then you are going to get minus j cap. Right? Now similarly, what we did in dot product, if this vector A is represented like this and vector B is represented like this, how do you get the dot product? You can do it similar. You can do it one by one, this to this and this to this and this to this. Similarly, you can go on doing that, and wherever I cross j comes, something will come. You can use this and write these symbols. Wherever j cross j comes, that will be 0. Wherever I cross I comes, that will be 0. So ultimately you will be left with these terms. You can solve it and see, or you can use the determinant method. You simply write I, j, and k and use the determinant to solve it. How do you do that? You write I cap into this minus this into this. You write j cap into this minus this into this. Okay. Similarly, you write k cap this into this minus this into this. You may already be knowing this determinant thing, right? No, or you can simply use the multiplication thing and eliminate these terms and use this one to get the minus sign or the plus sign. So whichever method you do, it will be okay. It will know, like you're multiplying this with all the terms and this with all the terms and this with all the terms, and just eliminating one by one, you will get this. You can see this example and understand. We'll just see a question here. So a force on a charged particle due to electric and magnetic fields is given by this one. Suppose E is along the x-axis, so the force is given by QE plus Q in QV cross B. So these things we have to study in electrostatics and magnetism. So B is magnetic field, E is electric field here actually. So E is given along x-axis and B is given along y-axis. In what direction and with what minimum speed V should a positively charged particle be sent so that the net force on it is 0? What direction should V be? The velocity of a body. So from the origin, let's say a charge Q is there, and from an origin this is going to be thrown. Which direction are you going to throw so that there is no force on it? So if you see this total force on a charged particle traveling in an electric field and a magnetic field, you see that this represents two terms, QE. This is the force due to the electric field, and this is the force due to the magnetic field. Okay, and the sum of these two gives you the resultant force actually. Now for F to be 0, we know that the direction of QE should be equals to minus of QV cross. This is the force due to electric field and this is the force due to magnetic field. so that both of them cancel each other, so that the net force on that will be 0. Now, since this force doesn't depend on the velocity, so whatever the velocity, whatever the direction of the velocity be, the force QE is going to act along the E direction only. So it is going to act along this direction. Now, for the other part should act along the opposite direction, this particular part. Then only this and this can cancel, so that the net force becomes 0. So now, what is the direction of V cross B? You know. So this is the direction of V cross B. You also know the direction of B. So this is the direction of V cross B, or let's say QV cross B, and this is the direction of B. So what should be the direction of V such that the cross product is in this direction? So we don't have to find the angle of, the direction of cross product, but we have to find the direction of the other vector. What is the direction of V vector? Sorry. So what will be the direction of V vector such that V cross B will be in this direction? So let's say, I'll tell you. So this is the direction of B already given. So what will be the direction of V vector? If you see this, if I draw this one, such that V cross B will be in this direction. So if you draw another vector in the z-axis direction, so see this is the z-axis direction. So I have drawn it by this symbol. Okay, you can understand that this vector is coming towards you. It is perpendicular to the plane and coming towards you. So if you do V cross B cross z-axis, V cross B, sorry, z-axis to B, then you will find that this is the direction of V cross B. That means the direction in which the charge has to be thrown is positive z-axis, right? So this is what it is asking. In what direction and with what minimum speed V should a positively charged particle be sent so that the net force on it is 0? So the V vector direction will be z-axis. If you see z-axis, then V cross B, if you do, V is z-axis. So from z-axis, if you do to y-axis, so this is K cross K vector, no? Because this V vector is along positive z-axis, so it will be K. We have just assumed it. So K cross the B vector is along J vector, right? So this gives you minus I vector, right? No, so this is your minus I vector. So this is in this direction. So we know we know now that the V vector should be along positive x-axis, positive z-axis, right? And the magnitude should be something like this, so that the velocity will be E by B. So the charged particle should be sent with the velocity E by B in positive z-axis direction. This is how we solve this, right? So that's it for the vector chapter. So we'll see some questions, and maybe with a new topic I'll come for the next chapter. Thank you.